what's the plan?
And we're trying to get everything consolidated and get a cohesive set of questions to ask you.
Roger, 15, we copy.
That sounds real good. Appreciate it.
Anything else to report?
Right, we haven't talked about landing for several days.
Believe none of what you hear, question everything you see. That's affirmative. That's affirmative. That's affirmative.
Welcome to Richplanet TV. I'm Richard D. Hall. Now you can find an update on my legal situation from this link, and I will probably be posting further updates there soon. Today I'm going to give an update on the Mini N machine and describe my findings about this very intriguing device. It is a little bit technical, but I have done my best to explain things in a way that anyone can understand, so stick with it. I apologise for the time it has taken me to put this video together. As you may know, I am still involved in legal matters which divert a lot of energy away from things that I want to get on with. Now, in order to understand what an N machine is and to see a detailed description of the experimental machine that I built, please watch show numbers 314 and 315 before watching this. An N machine is the name given by Bruce De Palma back in the 1980s for a particular type of homopolar generator. A homopolar generator consists of an electrically conducting disc which is spun at high speed inside a magnetic field, resulting in a DC voltage being produced between the rim of the disc and the center of the disc. Electrical power can then be drawn off from the rim and the center using brushes. The magnetic field can be produced using two circular magnets positioned either side of the disc. Usually the magnets remain stationary while the disc spins in close proximity. However, Michael Faraday discovered that if the circular magnets are attached to the conducting disc and then rotated with the disc, known as co-rotation, a voltage and current are still produced. This puzzled Michael Faraday because there is no relative motion between the magnets and the disc, and he was so surprised that this became known as Faraday's paradox. Researchers who have investigated the co-rotating homopolar generator, such as Bruce De Palma and Adam Trombley, built a number of machines in the 1980s and 90s and made claims that this type of machine, if designed correctly, could produce more electrical power out than the power required to drive the machine. If true, this seems to break the law of conservation of energy and seems to indicate that a free source of energy can be extracted from within space itself. Now, I recently built a co-rotating homopolar generator in order to investigate their claims. It is essential that you watch show number 315 in order to understand what was built and what it does. As I explained in the previous video, my machine is not capable of producing more power out than in due to the fact that I am using carbon alloy brushes, which produce a significant amount of drag on the rotating machine. And this drag absorbs an amount of power from the drive motor which is well in excess of the electrical power output capability of the machine. However, it is still possible to look for the over-unity effect by switching the electrical output load on and off and measuring the subsequent change in input power rather than the total input power, then comparing the change in input power with the change in output power. This eliminates the power consumed by friction and should show whether a lower friction machine could produce an excess of power. For example, if an electrical load of 50 watts is switched on, then the input power, according to conventional physics, should increase by at least 50 watts. If the input power increases by a lesser amount, it means there is an excess in the output power coming from somewhere. By carrying out a number of tests on my machine, the results showed that the increase in output power was indeed consistently about 33% higher than the change in the input power, indicating a possible over-unity type effect. De Palma and Trombley reported much higher ratios, in the region of 400 to 600% more out than in. Now, I believe I now know why their machines achieved higher, and I will explain this in today's video. In order to explain my results and theirs, I am going to use graphs which show the output current of the generator on the x-axis and the input and output power of the generator on the y-axis. The current shown on the x-axis is varied by using different values of load resistors across the generator's output terminals. As you will have seen in the last video, the tests consisted of switching the load on and off using 2 circuit breaker switches. Each time these switches were thrown, the input and output parameters were recorded just before and just after the switchover. Using the results from the tests, I plotted points on the graph for the total output power obtained by multiplying the measured current and the measured output voltage at different values of load. So each dot or point on this graph represents the values measured immediately before or after the circuit breakers were opened or closed. The data points represent the total measured output power. A straight line is produced as expected. As we move to the right along this graph, by reducing the load resistance, the output current goes up and the total output power goes up proportionally. The slope on this line is the output power divided by the output current, which is equal to the output voltage of the generator and is a fixed 0.445 volts. Now you will notice that some of these points are not quite in line with others. This is because during the tests the magnets became quite hot, and heat reduces the magnetic field strength slightly of neodymium magnets, resulting in a reduced voltage output. When the magnet cools again, that magnetic field strength usually returns. However, there can be a permanent reduction in the field strength, and this is what happened with the magnets. But I estimate that the total reduction in field strength over the testing period was no more than about 5%. This is why some of these data points are not perfectly in line with each other. I can now draw a solid line over the data points by defining an equation for that line. In this case, it is y equals 0.445x, where y is the output power and x is the output current. 0.445 is the fixed voltage output. The slope on this line, 0.445, represents the fixed voltage output of the machine. Now, when an electrical load is applied to an electric generator, the shaft experiences what is known as back torque. Now, this is a bit like putting your hand on the shaft to try and slow down the rotation, and thus the drive motor has to provide more power to overcome that back torque in order to maintain the same speed. But with my machine, when the load was applied, the measured input power was 33% less than it should have been, which means that the back torque, which is directly proportional to the input power, was also 33% less than it should have been. Let's now plot on the graph the data points that were recorded for the incremental input power. The blue dots on this graph represent the incremental input power. These values were derived by measuring the drive motor's input power both before and after the load is turned on or off and taking the difference. The values were recorded over a range of different loads. We can see that the values are consistently lower than the output power. These values should always be above the red line, not below it. This straight line here represents what one would expect the input power to be. The data points are consistently about 33% lower than they should be, suggesting that 33% extra power is being produced from somewhere, and I will come back to this. What I wanted to do was to characterize this line and come up with an equation which defines exactly what the reduction in input power is and how it behaves. However, the problem I had is that these data points are not perfectly lined up, therefore it is not possible from this data to characterize what sort of line they are following. For example, are they following a straight line like this? Or are they following an x minus x squared function like this? Or an x squared function like this? Further tests revealed the answer, and I will explain. In order to get more results and to try and shed light on this anomaly, I suggested in the previous video that using a faster motor might increase the observed effect. A faster motor would produce a proportionately higher voltage. Now, a viewer very kindly donated some Bitcoin to me so I could purchase a variable speed motor. I was concerned that a faster motor would be dangerous, so I also built a safety cage around the generator. This arrived in the post today. Now, if you remember, I put an appeal out asking if anyone had a faster motor, and someone has donated some money. So I've been able to buy this brand new motor, which is 1.5 kilowatt servo motor, and is controlled by this box here of power electronics, which can vary the speed of the motor up to 5,000 RPM, which is considerably faster than the other one. Now, I'm convinced now that there is definitely an over-unity effect with the co-rotating homopolar generator, and I'm trying to characterize that. I need to find out how the characteristics are going to change at a higher speed so I can pin down this phenomenon and define it properly, and running it at a higher speed is hopefully going to achieve that. Now, this motor has a flange. You can see here on the front, it attaches to the front, not to the bottom, so I've bought a piece of aluminium bracket that's going to fix on there. We'll drill some holes in that, and then obviously that will then fix onto the bed. I've also got another coupler to attach that to the generator. I'm going to replace the power connector with this one, which will allow it to go through the control unit so that the power can be measured. So I've removed the motor and replaced it with a new one. You see it there, it's quite a bit smaller, but I've had this running at 2,500 RPM and it turns the generator great, and it was only drawing about 400 watts, so we should be able to get this up to perhaps in the region of 5,000 RPM. But in order to do that, obviously I'm concerned about safety, so what I have done, I've built an enclosure, a cage, so the end machine is going to go inside here, and I've bolted it to the floor and to the walls just in case the whole thing disintegrates when it's running. I don't want to get covered in shrapnel. Right, I've finished building the cage, and the end machine, mini end machine, is inside here, which is this is all bolted to the floor. We've got some finer mesh behind it, and I've also got the safety gloves, safety glasses. I'm probably going to wear a thick coat as well. Yeah, I'll just switch it on. And this is the new motor control unit here. So this motor has got, as I said, an additional control unit. Let me just switch it on. Oh, I need to switch that on first. I don't know if you can see that, but there, that's 2.4. So the electronics in here is drawing 2.4 watts, which is good because that's quite a small amount. Now you can set the speed on here. There, we've got it set to 2,000. So if I set it to 2,500, which is lower than what I've been setting it at, and just start it up. So that was 0.371 volts there, which is what you'd expect, slightly lower than at 2,900 RPM. Okay, 4,000 RPM. Recording. Let's go. I also fitted a better power meter to the control panel to measure the input power. We see it here. Now this meter goes down to 1/10 of a watt. We see it there. It also said on the data sheet that the sample rate was less than once per second, but this turned out not to be the case, which miffed me a bit. However, it still had a faster sample rate than the previous one and produced more accurate results. Now, I managed to get some results with the machine running at 4,000 RPM, which is significantly faster than 2,900 of the previous motor. However, this proved inconclusive for a few reasons. Firstly, the input power, which should have been fairly fixed when running at a fixed load, was varying around quite a bit. This made the readings inconsistent, too inconsistent to draw any conclusions. These graphs show the input power in blue and the output power in red at 1000 RPM, 2000 RPM, 3000 RPM and 4000 RPM. But the input power is varying around a lot, so I could not get accurate data points to be able to plot on a graph. Secondly, I did not have a value for the efficiency rating of the motor, therefore could not calculate the exact input power being used to drive the machine. Having exhausted the tests with the faster motor without getting conclusive results, I decided to replace the copper disc inside the machine with a steel disc in order to increase the output voltage of the generator to see if the effect would increase. This required a major overhaul of the machine. I had to disassemble all the parts and remove the magnets. This was a difficult task and took the best part of a day to get these magnets free using dozens of wooden chocks. I then had a new copper shaft made and reassembled the machine with the steel disc. Here it is in the middle. This is the old copper disc that was replaced. We cut the shaft here to get it free, and then, as I said, we removed the magnets and then we fitted a new shaft and a new steel disc. Okay. Now, by doing this overhaul, I resolved a problem that I hadn't realized was there. The steel housing, which carries the rotor brushes, that's this thing here, had been scraping slightly against this copper shaft, which was contributing to the unstable power readings that I showed earlier. Now, once the shaft was assembled with this problem resolved, the machine ran smoother with a much more steady input power reading. Also, the voltage increased from 0.445 volts with the copper disc to 0.516 volts with the steel disc, which is a 16% increase in voltage. Because steel has a much higher magnetic permeability than copper, which means that a magnetic field going through a steel disc is maintained at a higher level than in a copper disc of the same size. So the higher magnetic field means that a higher output voltage is generated. I then ran some further tests using the steel disc machine with the original 2900 RPM motor, and this produced very interesting results. I won't show the full video of the actual tests here. You can find the test videos in part 2 or 3, so anyone who wants to analyze the tests can derive their own data. Now, in order to explain the results, as I mentioned, I am using a graph which shows the output current of the generator on the x-axis and the input and output power of the generator on the y-axis. Before I show the results using the steel disc, I'm going to go through a little bit of circuit theory. As I explained in the previous video, the machine's output is an electrical circuit consisting of various things in series. They are the shaft and disc, the brushes, the circuit breakers, and the load resistors. All of these things in the output circuit have electrical resistance, and the output voltage across them is fixed. In our case, it's 0.516 volts. We can simplify this circuit into the fixed resistances, i.e. the shaft, disc and brushes, and the variable resistances, i.e. the circuit breakers and the load resistance. So we effectively have a circuit with two resistors in series, and one of these resistors can be varied. The resistance is varied by adding or removing load resistors in the load bank. Now this circuit has a known output power characteristic which I am going to draw. As we saw, the total output power across the whole circuit is a straight line. We can also plot the power going to the load resistance as that resistance changes. This produces a y equals x minus x squared curve. Now the power going to the rest of the circuit, i.e. the fixed resistance of the brushes, disc and shaft, is a y equals x squared function. This power cannot be utilized and is effectively trapped inside the machine, i.e. inside the shaft, disc and brushes. Now if we add the value of the two purple lines together at any point along it, they always equal the red line, i.e. the total output power. Now the power going to the load is the actual usable power which could be used in the real world to power electrical devices. If the load resistance is infinite, i.e. at open circuit, we are at this point on the curve. The middle point on the curve here occurs when the fixed machine resistance equals the load resistance, and this point here is when the load resistance is zero, i.e. in a short circuit situation, and you cannot go beyond this point. Now the total output power, i.e. the straight line, should never be more than the input power. Otherwise that means more power is being generated than the power going in. So in conventional generators, the input power should look something like this. If the machine was 100% efficient, the output power line would be the same as the input power line. So as I said, in the real world, we should expect the input power line to look something like this, always greater than the output power. Now let's have a look at the results obtained using the steel disc mini N machine as we did with the copper disc machine. Now the total output power line, the red line, is slightly steeper than before due to the increased output voltage. The red dots this time make a perfectly straight line which can be characterized as y equals 0.516x. 0.516 is the fixed voltage output of the generator. Now let's plot the incremental input power points. The first point to note is that the results are consistently below the red line, indicating that more power is being generated than is being put in. Secondly, the input power is not following a straight line. As we go from left to right, the blue line is getting further and further away from the straight red line. Therefore, it is a curve. The reason why I do not have points on the curve higher than 140 amps is because I could not get the load resistance any lower in the output circuit. The two switches I was using have a finite closed circuit resistance, and I could not make that resistance any lower. If I'd had a lower resistance switch, I could have derived points on this graph a little bit further along this curve, but I am quite sure that they would continue to follow the same mathematical curve. That's just how physics works. So there is enough data here to be able to confidently speculate the rest of the curve with a mathematical equation. And here it is. It is an x minus x squared type function. This is the equation that the input power appears to be following. Note that it should be following the red line or higher, i.e. the same or greater than the output power, but it clearly isn't. What you are looking at here with this blue line, as far as I am aware, is not documented in any physics, engineering or science paper. If it is, please send it to me. The blue line shows the reduction in the machine's input power as the machine generates more power when the load resistance is reduced. It might look like just a curved line, but this line could represent an unimaginable breakthrough in physics. And you saw it here first. The blue line, which is the power required to drive the machine, is showing a decrease as the power output of the machine increases. The back torque on the machine is proportional to the blue line and is therefore also decreasing in this part of the curve. Both Brewster Palmer and Adam Trombley reported that there was a reduced back torque in a co-rotating homopolar generator, but I am not aware that either of them characterized it as I have done here. I repeat, this line could represent an unimaginable breakthrough in physics. And before I go on, I'm just going to define my hypothesis for the record, which states, this is hypothesis of Richard D. Hall, and I'm reading this on the 9th of the 9th, 25. Here goes. The expected input power of a co-rotating homopolar generator running at fixed speed is equal to its output voltage multiplied by its output current, defined by the equation P equals V times I, where P is the electrical input power, V is the output voltage, and I is the output current. However, experimental observations have shown that this may not be the case, and the true power is P equals V times I minus K, which is a constant, times I squared. Now K, and I've marked it K RDH, the RDH constant is a value in ohms. The value of K is determined by the specific design of the machine's parameters, and it is not understood exactly why such a machine exhibits a lower than expected input power. This observation is of huge significance because it means it may be possible to exploit such machines to produce free energy, which may be being extracted from the quantum vacuum field. So that's my current hypothesis. Maybe I should publish that. Okay, now just considering this graph, if I were to get the current up to around 350 amps, the apparent over-unity factor would increase significantly from 33%, such that the output power would be 4 times or more than the input power, which is exactly what Bruce De Palma and Adam Trombley did with their machines. The red line represents the total output power being generated by the machine, but not all of that power is being supplied to the external load. Therefore, not all of it is usable. We can add in the data points for the power going to the external load. And this is exactly what is expected. And I can overlay the mathematical curve on top of the points. If I now compare the usable or external power curve with the curve we just derived for the input power, they are following the same shape, i.e. it's an x minus x squared type function. However, as we can see, the input power curve is larger. This means that the usable power is still less than the input power. Now, if I draw a line at the 200 amps point, we see that the input power is 58 watts, the output power is 103 watts, but the usable output power is only 33 watts. If we look at the output circuit, we can map these figures onto the circuit diagram. Total output power of 103 watts minus load power 33 watts equals 70 watts. That means that 70 watts of power is being consumed within the shaft, disc and brushes. Now the brush resistance will be making up the vast majority of the resistance of these components, probably by a factor of 10 at least. So if we separate out the brushes in the circuit, it means the 70 watts can be split into 8 watts for the shaft and disc and 62 watts for the brushes. So if the brushes were redesigned such that their resistance was 1/10 of what it is now, and we add the 9/10 that was brush resistance to the load resistance, the load power would increase by 55.8 watts, making a total of 55.8 plus 33, which is 88.8 watts of usable power, with the input power still at only 58 watts, thus producing significantly more usable power out than in. So the load power curve would now look like this. So redesigning the brushes with much lower electrical resistance would require a liquid metal contact with the disc, and I will come back to this. Now that I have shown that there does appear to be a genuine over-unity effect with this type of machine, let's now plot the same curves for Bruce De Palma's Sunburst N machine, because we have all of the data we need from Professor Kinchlow's 1986 report to do this. The report specifies the input and output power and the output voltage and current in this table. We also know that the shunt used, i.e. the external load resistance, was 31.25 microohms. The output current was 4776 amps, the output volts 1.28 volts, output power 6113 watts. The incremental input power was 6028 minus 5226, which is 802 watts. We can calculate the external output power using the value of the shunt. So this is I squared R, which is 4776 squared times 0.00003125 ohms. This equals 712 watts. So we see that the power to the external load was only 712 watts, which is less than the 802 watts of the incremental input power. So as with my machine, the majority of the power was being dissipated internally, not in the external load. Let's now plot these figures on the graph. So first, the total external power that the machine generated. We have a single point here at 6113 watts at a current of 4776 amps. The voltage output was 1.28 volts, so we can draw a straight line with a 1.28 volt slope, and we see it cuts through the point we plotted. Note that this line is steeper than the line on my generator because the voltage is higher. We know that the incremental input power was 802 watts, so we can mark that point on the graph in blue. From my tests, we know that the input power curve follows an x minus x squared type function, so we can draw an x minus x squared type function so that it intersects that known point. And here it is. We can now plot the power going to the external load, which we calculated at 712 watts. Here is the point in purple. Again, this follows an x minus x squared function, so we can plot the curve so it intersects that point. So looking at this with De Palma's machine, because he managed to get further along this curve, he produced an output power of 6113 watts with an input power of 802 watts. Over 6,000 watts coming out and only 800 going in. And that's because he's further along this curve, meaning the machine was putting out over 7 times more than the incremental input power. And this is what boggled the mind of Professor Robert Kinchlow. However, only 712 watts were in the external load, the usable power. So this machine, due to the carbon brushes, has the same limitation as mine. But De Palma would only need to reduce the resistance of his brushes by a very small amount in order to get more power into the load, such that the usable output power is also more than the incremental input power. In Kinchlow's report, he states, a number of techniques could be used to reduce the friction losses, increase the total generated voltage, and the fraction of generated power delivered to an external load. Okay, so here Kinchlow, Professor of Electrical Engineering at Stanford, has put his finger on the key factors to be able to produce a truly working free energy device. In order to increase, he states, in order to increase the fraction of generated power delivered to an external load. That's how he puts it. Now, the only way to do this is to reduce the resistance of the fixed resistance part of the circuit, which is the disc, rotor and brushes. Now the resistance of the disc is small compared to the brushes and would be very difficult to reduce. So making the brushes with extremely low electrical resistance is the key. And this means using liquid metal contact on the rim of the disc. To get the resistance lower also means using a larger surface contact area, which could mean having liquid metal in contact with the rim of the disc all the way around the perimeter. Using metal liquid contact will also reduce the frictional force of the brush on the disc, thus minimizing frictional losses. In my opinion, from my results and looking at De Palma's results, it can only work by using liquid metal contacts within the machine. And this is exactly what both Trombley and De Palma were striving for in their later machines. De Palma used mercury and Trombley used sodium potassium eutectic known as NAK78. If we just consider De Palma's later machine pictured here, it is possible to put two end machines, just like this part here, two of these on the same shaft. If the magnets in each machine are placed with opposite polarities, so you've got the magnetic field going that way in one of them and then this way in the other, but they're on the same shaft, such that the field through each conducting disc is going in the opposite direction, one machine will have its positive terminal on the rim and its negative terminal on the shaft, whereas the other will have its negative terminal on the rim and the positive on the shaft. So the two generators can just be connected in series by fitting them on the same shaft, just like connecting two batteries in series. And the shaft, which is the positive of one and the negative of the other, connects the two together, resulting in twice the output voltage. This means that there is now no terminal on the shaft, and the voltage terminals are on the rim of the two discs. So there'll be two of these discs, and one is positive and one is negative. Therefore, two identical liquid brush arrangements could be made around the rims of each disc. And this is what we see in this image of De Palma's later machine. The two end machines on the same shaft with two magnets either side of the rotating conducting discs. So these are the positive and negative terminals marked here, and the fixed copper containers here contain liquid mercury which is in contact with the rotating disc. The machine is enclosed in a glass case because mercury is toxic, and we see two funnels on the top of the machine, which is where the mercury is poured in. Now, turning now to Adam Trombley's machine, he too realized the critical importance of using liquid metal to be able to achieve a usable over unity machine. Okay, so I've picked out a few key drawings of Adam Trombley's patent, and I'm just going to try and explain it in layman's terms. So just to give you a sense of scale first, this rotating drum is 14 inches in diameter, right? And the whole thing rotates apart from this bit inside here, which is fixed. So that part there, right, is this bit here, and that slot there is what this engages with here, right? So this all remains stationary. This is the brush, the entire thing, and it's made in two halves. The drum is also made in two halves, so that's one half and that's the other half, and they get, so this gets put in place here, and then the two halves get put on, and you've got a very small air gap between that surface there and this surface here, right? And similar with this is an electric coil. A similar small gap between that surface there and this surface here. So just to go through the sort of functioning of it, we've got a shaft rotating at 7,200 RPM, and on it, fixed on it, is a steel disc. Now this is more of a cylinder shape than a disc or a drum shape, but that's your rotating disc there, right? Which is inside here. Now on it, this is a contact, right? So that's where it's going to make contact with this thing here. Now we'll notice that there's material all the way around here. This is iron, right? And this all rotates together. So this is an electromagnet wound like that. So you've got a north here and a south here, north here, south here. So there's electromagnets either side. So these magnets fit around this rim, but they don't fit to it. There's a very small gap, right? So you've got electromagnets all the way around there. And the purpose of this is that, so you will get the north hole here, the magnetic field comes out the magnet, it goes around this magnetic circuit, which is iron, and then it comes back into that magnet, and then you've got another circuit there. Now the purpose of this iron is to try and keep this magnetic field as high as possible by encasing it in a highly permeable magnetic material such that the field strength is as strong as possible going through that steel disc, right? So obviously if you've got a magnetic field going in that direction and then you've got motion coming towards the screen, you'll get electric current. A massive electric current goes up and out through here. So this is your positive or negative terminal, the whole thing. So where the contact is here, that there sits in. So this rim here, this is an exploded view of it, right? So you see here we've got copper braid, and this is copper as well around it, and then your contact, which is moving, so this remains still, your contact which is moving sits in there, and it's then wetted with this liquid metal material. So there's very little contact between the actual disc, which the edge of it is there, and this braided material, and what makes the contact is the liquid metal, which will be sitting inside here. So this whole thing is spinning around it. The entire thing spins round. As I said, this bit inside there remains stationary, which is this arrangement here. And as I said, it generates 15,000 amps. 15,000 amps at 43 kilowatts. Now we see this dotted line here inside the shaft. That's the wires going to the electromagnets. So the electromagnets have to be powered externally, and this is how they're fed. And this is the rotor brush arrangement here. This doesn't show the actual brush arrangement, but there's another system like this for the rotor brushes going around there. So in this machine we don't have the permanent magnets as you have with De Palma's machine and my machine here, right? You have an electromagnet which is outside the disc and the field comes through here, but you still have the same concept because you've got a rotating disc, you've got something which is generating a magnetic field going through the disc which is rotating with it, right? So it's exactly the same principle, co-rotating homopolar generator, but in this case it's got a closed magnetic field path. That's why it's called a closed path co-rotating homopolar generator. So you can see the trouble that Trombley's gone to here to engineer this. The tolerances and the accuracy of this would need to be extremely refined in order to get the contact running in that gap at 7,200 RPM. It would have to be very well balanced. What this shows me is the trouble that he's gone to get this very low resistance contact with the disc, which, as I explained earlier, is what's needed if you're going to create a free energy device. Now if you want to see the full patent, follow this link, but you can see there how much effort he's gone to in order to achieve liquid metal resting all the way around you know, the circumference of a disc. Okay, now this is what Bruce De Palma wrote about Trombley's patent. Recently, the international patent application of Trombley and Kahn, assigned to Acme Energy Company of San Rafael, CA, has become public property under the Patent Cooperation Treaty and can be obtained from the International Bureau of the World Intellectual Property Organization. A copy of this patent application is attached. The difference between the international patents and the US patent system is that in the US, the material of the patent is secret until the patent is granted, while overseas, the application itself is the basis of the patent, which stands until challenged by a third party. Thus, although Adam Trombley, the senior designer of the machine, has received 2 written gag orders from the Pentagon Department of Defense forbidding him to reveal details of the machine upon threat of 10 years imprisonment for violating security relating to homopolar generator design, through the very nature of life itself, by a totally automatic process, the attaché document falls into the public domain. The attached patent application and drawings represent the result of the expenditure of $290,000 in 2 phases. The Department of Defense imposed secrecy has prevented any recompense whatsoever from accruing to the men who performed this work. What is described is a machine, an electrical generator whose output exceeds the input by a factor of 4.92. Now, I've also got just something from Adam Trombley's website. It says here that the US patent application was rejected twice on the grounds of impossibility that the machine could work, and then the authors were warned not to publish any information on the basis of violation of secret homopolar generator work being done concurrently by the Department of Defense. Now, after I finished my tests, I decided to look into whether liquid metal brush systems were commercially available. I contacted maybe 10 or so companies that make brushes and slip rings. They all tried to sell me carbon alloy brushes. Mercury is generally not used in industry due to its toxicity. Liquid gallium alloy or Gallinstan is another option, but that does have problems with corrosion. It tends to react with both copper and steel. I could not find any suppliers who could produce liquid metal contacts that could be used on a high-speed rotating machine with a large circular conducting disc. Developing a machine with the right electrical low-resistance liquid metal contacts, as described by Trombley, would cost quite a lot, which I don't have. Now, I have found more recent patents along the same lines. This one from 2009 by Oak Ridge National Laboratory, which can be found from this link. It states, this invention was made with United States government support under contract number DE blah blah between the United States Department of Energy and UT Battelle LLC. The United States government has certain rights in this invention. Now, in the latest video, I mentioned Dr. Tom Vallone's research into co-rotating homopolar generators. This is his book, The Homopolar Handbook. Now, Vallone basically debunked the concept of overunity, putting his observations of it down to his own measurement error. So let's use the same graphs to map out Vallone's machine and see whether he was being fair to Brewster Palmer. His figures are given in this table on page 30 of his book here. The external resistance he was using was 20 microohms, and from the figures we can plot another similar graph. Here is the recorded total output power point, and here is the resulting output power straight line. We see that the incremental input power shown by the blue dot, 17 watts, was indeed, again, lower than it should have been, i.e. lower than the output power of 24.7 watts, which is anomalous and suggests extra power is being generated. Conventional physics says that the input power should be above the red line, here, for example. But he could not accept that the input power might be lower than the output power and did not consider that it could be following something other than a straight line, because it would go against conventional physics. So he just put this observed point here down to measurement error. He said this discrepancy here, this huge discrepancy, must be a measurement error. Look at the size of the error. He didn't realize that the input power was in fact following an x minus x squared type function, and he assumed the input power must be somewhere along this straight line. Now, I believe Vallone was seeing the effect, but just didn't want to believe his own eyes and didn't want to investigate it any further. From reading his book, The Homopolar Handbook, it seemed to me that Vallone was intent on debunking De Palma rather than investigating De Palma's claims properly. Nevertheless, he got a PhD out of it. Now, as to the question why? Why does a co-rotating homopolar generator behave in this way? Well, I'm going to leave that for the physicists to argue over. I think it might involve relativity. Having said that, I still don't think anyone has fully explained Faraday's original paradox, never mind this paradox, although they're probably part of the same paradox. Okay, so I have shown to my own satisfaction that this type of device most likely can and does generate free power somehow, but it would take a considerable amount of money and expertise to build a prototype machine that could provide practical free energy at the flip of a switch and would require no fuel. At one point in my journey investigating this machine, I thought that if I built a larger machine using commercially available carbon brushes, it would be able to produce over unity power. So I designed such a machine, and I was in talks with a local engineering company who were going to do the machining. The machine was going to use 64 largish neodymium magnets, 8 on either side of metal discs, fitted in slots, fixed together, 4 discs mounted on the same shaft, and I calculated that that would produce an output voltage of 12 volts if spun at 4,000 RPM and possibly 10 kilowatts of power. But having derived the final results that I've just explained with my machine, I abandoned the project because I now do not believe that it can be done without the specialist design work on liquid metal contacts. Now, in order to find this out, I spent 6 months designing, building and testing a machine to satisfy myself as to whether the claims about this type of device were true. And I did all of it while under extreme pressure of a lawfare attack, which is now threatening to take away my home from myself and my 10-year-old boy. You can only find out the truth by carrying out real-world investigation, which takes time, know-how, persistence, not to mention money. You cannot find anything new out just by looking in existing physics books or quoting accepted laws of physics. You have to build something in the real world if you are going to be of any use to the cause of finding new energy solutions or indeed finding free energy. But let's be clear about what my research shows. Free energy devices were invented in the 1980s and 90s, but instead of assisting the inventors to perfect their machines and thus provide almost limitless free electricity without any emissions, the establishment debunked them and tied the inventors up with gagging orders and starved them of funding. The climate change scam has paved the way for ridiculous measures where money and the planet's resources are being stolen from the public via carbon offsetting, supposedly to mitigate climate change. The last thing this scam wants is a solution to their made-up problem. It is a scam because they already have the technology which would solve the non-existent problem of climate change. If the planet really was going to perish, this 1980s technology would have been used to solve the problem decades ago. But there is no problem. The other reason why such technology is prevented from reaching public use is that it would liberate the population from connection to the energy grid which they are currently so dependent on. Thus, control over the public would be diminished, and they can't have that. Energy dependency and climate emergency are 2 strands of the global technocratic prison which is currently being put in place. Technology, such as what I have described in these videos, could eliminate these 2 strands completely. Let's hope someone with a bit of money and some balls will help make it happen. Now, in the first episode of Richplanet Power, I said I was possibly going to investigate several alleged free energy devices. But do I really need to continue? Because I believe I have found one. I specifically chose this one first because I believed it had the most promise. You only need one. Is there anyone out there with the funding to be able to develop a liquid metal brush system for a large co-rotating homopolar generator prototype? Because that would be the next step. Now, there are many other devices that I would like to investigate in the same vein that I investigated this one, and each one could take up as much time and energy that I spent on this one. If I had the funding, a lab and a workshop and maybe a team of people, I could investigate all of them, and there are hundreds to look at. But alas, I don't have that luxury. I may start looking at another device in the future, possibly the Stan Myers water fuel cell, because I have already studied it in some depth and done some experimental work on it. But as you may know, I have a few things on my plate just now, so I'm not sure exactly when that will be. I have started writing a new book, which is going to take a lot of my time. I will state that the book is not about terrorism or false flags or even about free energy devices. I will reveal what it is about in due course. So I'm not sure when my next video will be or what it will be about. Please be patient on that front. Unfortunately, I cannot clone myself. You can find updates on my legal situation as they happen from this link. And please consider supporting me. And thank you to everyone, all my supporters, most sincerely, for all the donations. I've had over 2,000 donations, totaling over 150,000 now, which has all been spent on my legal defence and is helping to prepare the appeal to the European Court. So thank you. I couldn't have done any of that. I would have been in a completely different situation without all the help of my supporters. So yeah, I genuinely thank you. Remember, believe none of what you hear and question everything you see. I'm Richard D. Hall. Good night.
Believe none of what you hear, question everything you see.
I mentioned Fleming's right-hand rule in the last video, where this is the principal of operation, Fleming's right-hand rule of this machine. So the forefinger is your field, your magnetic field, which is going to go that way. Your second finger is the current, which is going to go out to the rim of the disc, and the thumb is the motion. Okay, so perhaps this can become the Richplanet greeting sign, a bit like Spock, who used to have this as his greeting sign, and he used to, I can do it with my left hand, but not my right hand. He used to say, "Live long and prosper." So it would be, believe none of what you hear, question everything you see, because the truth is over here.